Alright, guys? As soon as we say that you're...
This whole thing, this is language that he works in changes on a yearly basis, so he has a broader perspective on this. It's just basically my entire working career just been working with this .NET.
Okay, that was my default, but it wasn't good. All right, hello? All right, perfect. Thank you guys for coming today. And just want to let you guys know we've got judging going on in a couple of minutes. Thank you guys so much for the hard work that you've put in. Thank you guys again for showing up for day 2. I know that that was really hard for some of you guys. And without any further ado, I'd like to introduce our esteemed judges. And so whenever you guys are ready, one at a time, come up here and introduce yourselves to everyone. Ciao.
Hi, I'm Eric Lloyd, lead faculty for the BSCS program here today, and volunteer, so thank you.
Hi, I'm Bob Bungie. I'm IT faculty here at North Seattle College. In my spare time, I'm a social entrepreneur, currently working with organizations like Computing for All and Regenerate Cascadia.
Hi, my name is Matthew Bungie. I'm a back-end engineer at Tesla. I'm also his son.
Thank you so much. And last but not least.
Hello, I'm Dominic Giacoppi, currently employed by Netsimco Salix, which is a government contractor who has gone through many names. In Keyport, Washington, I do work for the Navy.
Thank you so much. Again, thank you so much to all the judges for being able to make it out on Sunday evening. And without further ado, I'd like to get presentation underway. I believe our first team is Changer. Would you come up here?
Hi everyone, my name is Binyam. I'm a computer science student at North Seattle College.
Hello. Yep. My name is Gabriel. I'm a student at Central. Yeah.
Hi everyone, my name is Nathan. I'm from Shoreline Community College. I'm also a computer science major.
Thank you guys. I think it's been a while since we have done such a public speaking kind of presentations after the COVID. Finally, we came out of the Zoom boxes. That's nice. Okay, me and my team today will present for you about the volunteer matching platform. We went for the first problem on the on all of the 4 problems listed out.
Okay. I like to recommend all of you guys. If you guys could go back a slide. Scan the QR code. It'll give you access to the website that we made or app. Scan the QR code. The password is Hackathon. So if you like, all of you guys can access that, please. So you guys can follow on with the website that we made. It'll give you more insight into what we built. The website or the app is called Changer. The origin of the name is that we want to impact students, especially high school students, to do an impact and be a change, be the changer of the world.
Okay, here's the problem. I'll read the problem real quick. Many individuals, particularly high school students, face challenges in finding volunteer opportunities that resonate with their interests and fit their busy schedules. Despite their eagerness to give back to the community, the process of discovering relevant volunteer opportunities remains cumbersome and time-consuming. And this hackathon challenge, participants will tackle this issue by designing and developing a mobile app or web platform. This platform will serve as a centralized hub connecting individuals with local nonprofit organizations and community service opportunities. By leveraging user-friendly interface and innovative features, participants will streamline the volunteer matching process, enabling users to easily explore, sign up for, and participate in meaningful volunteer activities. Through this initiative, participants will empower individuals to engage with their communities, foster social impacts, and create a positive change. Okay, here's the way how we approach the problem. We look for key terms on the problem, and we drive some important facts like the objective of the project and as well as the targeted audience from these key terms. The first one, me and my team, we went to decide on a web platform because of the singularity of this project. It's purposely used for high school students to connect them with non-profit organizations. So a mobile app might be somehow complicated. So we went up to do the web platform that would easily be integrated with students' Canvas applications or some other college websites. And also we knew that they are high school students, so we designed this web page to be really easily accessible and very simple, as well as to fit their busy schedule. We also try to fit in some calendar features into the platform. And also this would be easy and less time consuming, and my friends will explain the rest.
So one of the problems, or one of the things we wanted to tackle, is the amount of time we spend on our phones, especially social media platforms. How many of you guys, you guys wake up, the first thing you check is your phone, you open Instagram, you open Twitter, you swipe, and you're like, I need to get out of bed. Let me just swipe one more time. So if you guys have the app out, what we wanted to tackle is that instead of wasting time just looking at useless information, why not waste your time looking at opportunities that you can help with your community and volunteering and open volunteer work. We got inspiration from like Instagram and how you could socialize with other people and people that you follow and see what they're up to, see what other volunteering work if you could check. If you check the opportunities page in the website, there's also another inspiration that we got from Spotify. It checks what kind of music do you like. Do you like Latin music? Do you like hip hop? Well, in the Changer app, we check your inspirations and what you want to do. Because not everyone wants to, go to the beach and take up plastics, or you just want to be inside all the time. So there's usually just, if you check the app, there's the different types of opportunities that you could take, and the friends that have participated in this opportunity as well. And there's also upcoming events that show up in the app, if you could check. And you could also, if you're interested right now, the links do work. If you want to click in the app, they do take you to apps that you want to do. So yeah, it's high school students that we're tackling. And one of the things that we spent on COVID is just doom scrolling, just scrolling all of our lives and just gathering useless information. So we just wanted to tackle that of not using your valuable time into using something valuable in helping your community. Because we want to connect organizations with students to get their community service hours or just be an impact, or like the app is called, be a changer in the world.
All right, so now I'm gonna go in more in depth from my explanation from my friend Gabriel. We're going into the back end of the program that we're making, or the website, my bad. So here, I don't know why it's cut off, but this is like an organization class. This is the back end. So what we made is like classes for each organizations with these specific fields we want to put out in the website. So we put in out their name, their year founded, the schedules, the follow count, and their email. These are like brief descriptions we want to put on the website. And this is another class, organization list. This is the one that organizes all the lists because we want to, show them like how, like when you look through different pages, you see like a list of things, different things. That's what we wanted to implement. And so yeah, and here's the next part of the backend code. Like my friend Binyam said, we wanted to filter down the results based on, you know, their appropriation. So we made like different code for filters. So you can either search with a name or through year. So you can filter down the results. That makes it simpler for high school students to use. We just want this to be very simple and very, you know, effective to use. And here, this is just a helper class, to be honest. I just put this here so we can show you what we made. This is a scheduled class, so this is just, yeah, a small helper class, like I mentioned.
Something that came up that I wanted to add, but you know, we don't have much experience. An inspiration is with Canvas. With Canvas, I don't know if you guys know this feature, but you can connect your calendar from your Canvas to your own phone. And it's something that I use mostly, and I think it would be really, really useful for, you know, connecting your schedule with the program changer, with the volunteering work that you're doing with your own calendar. And I think that one of the, you know, things that we wanted to add, but you know, we're not that experienced, but yeah.
Yep, like Gabriel said, that was our idea. Sorry, can you go back? Yeah. Just one more. All right, so like Gabriel said, we want to, like, our ideas, our concepts are implementing, you know, connecting the calendars. So here we put input for the, like, your schedule, let's say, your personal schedule, and it would filter down by here, name, year, or, you know, you can search by schedule. So this basically is like a dashboard, basically. That's the whole concept. And so this is a sample code we used. In our ideas, we would want to use big codes like CVS, like just big codes of different kinds of organizations, but this is just a sample right here. So we have 3 organizations, you know, like those are the descriptions we want to implement on the website. We want to show them that. And yeah, here if you type in 2 or you input 2, it searches by name. You can search a name and it pops up. So that's our basic concept of, you know, a search bar. And this is the one for the year, so filtering it down by year. That's basically it. And so, like my friend Binyam said, we wanted to make this, you know, a web platform for high school students. You know, make it very versatile for them, easier for them to get, you know, to connect into nonprofit organizations. And such, our sole concept or our sole idea is to empower them. Our ideas were sending emails or notifying them or sending SMS. And so we want them to engage more into, you know, the communities and stuff like that. So that's basically it. So thank you very much for listening to our presentation.
Thank you.
Hello? Actually, do you guys have any questions for them? Any compliments?
I love the idea of scrolling through volunteer opportunities because, like, I have a really long volunteer history, but it's usually with the same couple of places. And expanding and doing it with other stuff and having other options and ideas is a really cool concept to me. Instead of having to always say, oh, I want to volunteer, I guess I'm going back to these same 3 places.
Yeah, you can use the mic for questions right here.
Well, yeah, like you mentioned, people have interests. They want to do different things. They don't want to do the same thing all over again. Just like with music, you don't want to listen to the same song 5 million times. So that's why we show the interest, one of the inspirations, and yeah.
Yeah, so basically, I like the part where you guys brought up like Spotify and like different interests of people's music and how you guys apply it to your app or webpage of like the interest, the different interests where people can look around and see the people that aligns with their own interests so that they could volunteer together, right? That's the thing, right?
Yeah.
From my understanding.
Yeah, we didn't want to reinvent the wheel. We wanted to make something that's familiar to all of us. We use social platforms like Instagram and stuff like that. We didn't want to we try to make it simple. We try to make it something that's familiar to us, especially us college students. We want to participate as well. So that's something that I wanted to, but we particularly just targeted high school students. But I think this would be good for college students too.
I love it, and once you guys bring it up, I'll be First one, signing up.
Yeah, we need like funding from like Bill Gates or something.
So I did have one question about if you were to find a activity you'd like, but you forgot to bookmark it. Is there a way to quickly find it again, or is there like, are you thinking of adding a bookmark feature, and what's it called, and how does it work on desktop?
Honestly, I kind of targeted more on the phone since the phone is something that we usually have all the time. And the phone now is more just so important to us. I mean, it's literally just like a computer in our pockets. But for the notifications and stuff like that and bookmarking, I think it's mostly like an inspiration from Canvas. How they do their notifications and stuff like that. You could do your own, or you could configure the notifications if you want to push and stuff like that. So yeah, I don't know if that answers your question, but.
Any other questions?
All good, thank you.
Hello? I just wanted to say one of the features I really liked from them was the integrating their school calendars with their volunteers calendar. Just because, especially in high school or even in college, being able to like sync both of those is great because then the volunteer can easily work around the student schedule instead of it being like it minimizes the amount of times I guess volunteers people have to talk to students. So I like that.
Yeah, it's just eliminating hurdles and stuff like that. Just make it as simple as I can just to clear the minds of these high school students and stuff like that, going through like SATs and stuff like that.
Sounds great. Anyways, thank you guys so much. You guys did great. Okay. I believe next team should be AIMD. Perfect.
I'll switch up and have you go wired just because we're using the wireless questions. Oh, do you have a fourth?
Well, it seems really stable.
What's the control for the slideshow?
Well, you're starting, so like you could have it for the first part. Just press. Okay.
Hello everyone, my name is David Kamara. I'm a student here at North Seattle College, business major. By order. Brown. Nicole Brown.
I'm Ann Alvarez. I'm a data analyst. I worked in the healthcare sector. I relocated to Washington and looking for work. So I thought this would be a good way to kind of get plugged in with the community. And this project interested me because I care deeply about health disparities. I volunteer with veterans and do anti-poverty work with members of U.S. Congress. So I thought this was a great topic.
I'm Ian Hammerstrom. I actually got my computer science degree from Western Washington University a number of years ago. I come back here just to take like a single one-credit class. Got wrapped up into this, so yeah.
My name is Michael. I'm getting a bachelor's in computer science right now, but I've already got a bachelor's of biology from UW.
The name is AIMD because, as you can see, the first letters of our name is like in order. AIMD. Yeah. Significance. All right. The challenge today, we're here to analyze healthcare data to empower policymakers and like healthcare providers to make sure that they make like equitable decisions to make sure everyone has equal healthcare. Yeah. So what we're gonna go through this whole is I'm going to go through the equitable healthcare dashboard, spurious and non-spurious healthcare, the data set, comparisons of variations for patients in different hospitals, and like no gender discrepancies and gender discrepancies. So yeah, I'll give it to you.
So for the CDC, health equity is that everyone has a fair and just opportunity to attain their highest level of health while acknowledging that there's been systemic injustices and some still ongoing that need to be addressed. So our process was we cleaned the data using Excel, looking for duplicates, outliers, columns with irregular text and data types. And we selected Tableau because Tableau Public is free and online and pretty user-friendly. And Ian thought of using ChatGPT to come up with some ideas for what we might do for the dashboard, which I thought was good. And then we just used Google Docs so we could all see what was going on with our tasks. So this dashboard could help the city policy makers. Well, first of all, our data set was very flat, so there's not a lot of variance, but this could help policymakers see if different insurance carriers were potentially overbilling, how Medicare compares to other insurance companies, and maybe if there's places that they need more medical access.
So this is an overview of the data we were working with. So each row represents a patient's visit to a given hospital with medical conditions, some information around them, when they got in, when they got out, and how much it costed. So yeah, we have several columns and then a row for each patient visit.
Okay, so here's where I come in. This is the part I worked on, and it feels weird looking at the slides I didn't look at before. Anyway, like this one, so like here we have our x-axis is year for both of these, and our y-axis is amount of money. The idea, like, I should have put it to be more specific correlation involved with this. Like this is spurious versus non-spurious correlation. So spurious correlation is like the idea of something that's things that aren't relevant. Like sometimes things can seem like they're tied to each other when they're not tied to each other. Like if you were to look at the number of drownings per month and the ice cream sales per month, you would see that there's higher ice cream sales in months with more drowning. That's not the ice cream causing drowning or drowning causing ice cream. It's rather just that when the weather is warm, people are more likely to want to swim or to buy ice cream. For this, like, I was trying to look at various ways of trying to see if there are things that had a relationship between each other and how those relationships factored in. So like up there, you see that this graph here on your left is the total billing amount versus the year. So looking at this, at first I think like, oh wow, 2018, that's a really cheap year. Like you go to the hospital in 2018, like you're only paying $5 or whatever, but like it actually turns out, and you look over here, that the average billing amount by year is roughly the same throughout. I guess on average, each person is getting billed about $25,000, or each visit is like $25,000 at the hospital. And I was irritated. I was thinking like, oh no, like it's okay if I have the little remote. Yeah, thank you. Yeah, I was irritated thinking like, oh wow, it's so hard to like, I've been looking for a few hours. I hadn't found anything in the data that seemed to show like there was anything actually that different in terms of like trying to compare different things and stuff. So like, I don't know where, oh, there we go. So there we go. So like, this is the next thing I looked at is like, are there gender discrepancies? So like this slide and the next two slides are slides where it seemed like maybe there's no discrepancy between gender really. So like here you have, oh my God. So like here you have admission type, gender, and medical condition. And I noticed that it seemed that it was basically the, how do you say it? this is letting us know that there's roughly the same number of people for every admission reason of each admission type. That's roughly the same amount of people. This is really important to establish because if there are a lot of people for one thing, like hypertension or whatever, then it could look potentially like you could get something that you're seeing in the data that's not actually a legitimate thing. Like if there was one of these graphs was really low, you might think that, how would I say it? So like when it comes to some things, it shows that between the genders that it's roughly the same number for each, which is significant for when I do find correlations between some things later on because, oh my God. But anyway, I'll go to the next one. So this is showing median billing amount, and we also are comparing this to the gender and admission type and medical condition. It shows that the median billing amount also seems roughly the same, regardless of gender or whether they're having elective, emergency, or urgent. Here we have elective, here we have emergency, here we have urgent. And each one of these at the bottom is a medical condition. So here we have arthritis for female elective, arthritis, male elective. That keeps going on through, so we have all of these, and it's showing that's roughly the same admission amount for each, which is important also for establishing where there can be discrepancies or where there cannot be discrepancies. So then, let's see, pressing the button. There we go. So here also for total billing amount. So this is the total amount of money spent of all genders for all of the years combined. So this is 2018 all the way through the most recent year. It's roughly the same amount spent for all. So this would be saying that roughly the same amount over all the years combined. However, if we look at this one, then there are some interesting discrepancies. It's a little bit challenging to discover like how much significance there is for this, but if you were to look at an average admission amount by admission type, there are some things that clearly stand out a lot. So like right here, we see for hypertension for women for emergency, it seems to be less than $2,000 below the average, but then for men for hypertension, which is right here for emergency, it's about $500 above average. So there's some of these, there's a really big, between the same factor that we're looking at here and the data, there will be a significant difference in the amounts. And that's one of the hard things when it comes to data like this, is that the same way with earlier how I mentioned the ice cream and drowning situation, like with this, it would be challenging to figure out like why there is such a big gap between some of these and why some of these there isn't really a big gap at all. Like it is fake data, mind you, so that's definitely part of it, but like with some like a good example would be like cancer. So here we have cancer for men, which is extremely close to average, cancer women, extremely close to average. Both of these are for urgent admissions of cancer, and that doesn't really make sense to me why some would be so close to the average for both genders, and then some there's very wild like discrepancy between the two. So like it does seem to be a correlation here, but to actually determine like the cause, we would need further data on like why that might be. This is another one. So this is this one. I feel like there's fascinating. So like, how many of you have worked with standard deviation before in a class? Okay, there's 1, 2, 3, 4, 5, 6. Oh no, that wasn't a 6. That was just somebody rubbing their chin. Anyway, so like, maybe one other person. Oh yeah, there's one person over there. Oh, good, you've worked with standard deviation. So standard deviation is how much the data deviates from each other. So you work out standard deviation by you look at all of the averages, then you see how far apart each of those averages is from the average of everything. And obviously I didn't do this by hand, I just did standard deviation in this, and it was very surprising to me how some of the data is very varied. Like, so for women's emergency asthma, there's a ginormous deviation in the data. There's like, compared to the others, there's like a $2,000 deviation, while a lot of these are fairly close to the middle, which is surprising too when you consider, like, I showed you like 3 boring graphs where like it was showing like almost everything being the same for everyone, which doesn't show deviation. That's just the factors I was showing before of like average billing amount, things like that. But like specifically like for this, like, it would be fascinating to see like why a number of these between the genders, like, there's fairly little deviation or like roughly the same deviation. Like, I guess another example, again here, same as the last slide, like cancer, men were urgent, very close to average for standard deviation. Well, this one also very close to the standard deviation average, while some are wildly off the chart, so to speak. And what else is there? Yeah, this was a slide that I did not do. Who was the one who did this one? Okay, here we go.
This is a tableau view that shows the median duration of stay for a given age range and medical condition compared per hospital. And so on the left here, we can see we have ages pinned at 60, so people in their 60s, and then with a medical condition of arthritis. And we can see throughout the different hospitals, the duration of stay can change quite a bit. And so that could potentially indicate they're kicking people out early. It could potentially indicate that they're being more effective in their treatment. Basically, you might expect that it would be a similar level across hospitals, but we do see that there are some differences. In the middle, we have age binned on 60s with diabetes. We also see there's a huge difference in the median duration of stays. And then at the end, looking at people in their 30s with diabetes, and again, it can range from 3, 4, 5 days of stays to up to 30 days or so across different hospitals. So, yeah.
Thank you for listening. Any questions? Or
also, if anyone wants to, they can challenge us to a dance off or whatever also, but questions are also a great thing.
Mr. Comedian. Feedback, questions, anything?
We have one from Vlad, it looks like.
So what do you think the immediate applications are of this? Of, okay, you have this data, you know certain discrepancies and stuff like that. What are the next steps that could be taken immediately?
Well, one of the challenges I saw is that, like, in Tableau, there are a bunch of standard things for organizing by geography, but that's really challenging with the data we had. We had, like, I don't know, maybe a few hundred hospitals or something, and we tried to see, like, if we could group them in somehow to see various things. However, like, there are, like, several hospitals, like, maybe about 5 or so of, like, each name that were, like, seemed really similar names, but, like, it seemed like there was nothing to get out of that. And if you tried to, like, put them in one graph, even when you tried to, like, condense those hundreds of hospitals to, like, a shorter list where they're grouped, like, it still is be like 15 or so. So, like, if you were to actually know what city or what the income level of the different neighborhoods and factors like that involved, like, that would have a definite influence on being able to see if there are geographic patterns. It would be cool too if there was, like, ethnicity data, socioeconomic data of the patients to see if that has a factor in the care, because, like, gender is one thing you can look at, but, like, without so many other factors, like, it's really hard to get much out of the data. Like, the first few hours, like, no matter what we tried, like, there must have been, like, a few dozen graphs we generated where it looked like basically all of the data was, like, the same with nothing different, which real data, like, you would even see something more correlations of some sorts than this, but, like, there was, like, yeah, like, if we had geography, socioeconomics, ethnicity, also, like, yeah, those would have helped us.
So just to round this all up, hello. So just to round this all up, my understanding of this is the intention of this project was to do an analysis of publicly available health data to determine what kind of various social economic factors might affect a patient's billing and staying in hospital. That was the goal, right?
Well, I didn't actually see. Did we see, like? I don't think we saw anything involving socioeconomic factors to, like, influence the healthcare outcomes. Like, we even did one thing that was cool in Tableau where you look at stay length and other things. There were a variety of ways we tried to look at the data, and it seemed like we weren't able to my knowledge, we weren't able to see socioeconomic factor side. Like, unless you like, did you see anything or?
So the data is fake. So like we cannot.
Oh,
it's
okay.
for privacy reasons.
Yeah, are we talking fake or are we just saying?
It's completely fake data.
Yeah.
Okay.
So this is what was given to us in that challenge.
It's really hard to navigate around all of that. It's not.
I actually considered getting like some actual because on Kaggle I actually have a professional certificate in data analytics from Google, and on Kaggle there are a wide variety of data sets. So I had considered the idea of analyzing other data that's on Kaggle, because I felt like that would have probably been better results in comparing it, but I did not spend the time. I was going to do that last night, but instead I was performing an event instead of doing that. But yeah.
Okay. And my other question was, your entire code process was taking the data set, doing some processing in Excel, and then putting it into Tableau, right?
Well, there was cleaning the data, which I believe was done by Anne, I believe, or I don't remember who it was. Yeah. And then after cleaning the data, there was doing various things in Tableau, such as there are various functions involving math, if you we were never given stay length data and some other things, but if you use some of the functions, you can do formulas to calculate stay length based on emission dates, discharge dates, and other things like that to try to further analyze.
Yeah, I'm just asking, it was all Excel and Tableau, right?
To my knowledge, yeah.
Yeah, okay, thanks.
Hey guys, just a quick question. Can you restate your problem and then restate what solution you found?
Yeah, do you want to, or it's whichever one wants to. Our problem was to analyze healthcare data, create a healthcare analytics dashboard, and also to look at the various demographic factors involved in healthcare. And
yeah, I mean, we were all doing our individual investigations, basically creating a variety of views that, if the views were given real data, could be used to potentially find inequalities in treatment or cost, things like that. So,
yeah.
Sure.
That's more or less my first question as well.
Oh yeah, I apologize. Sometimes I don't, when I hear a question, sometimes I misinterpret it in my mind.
No, that's fine.
Yeah.
Thank you.
Thank you. All right. Yeah, it's not going to tell them all. If you guys could please give a big round of applause for AIMD again. Thank you so much. And Namaste. Oh, perfect. Yeah, please give a round of applause for Bubble Data. They're up next.
Hey everyone, how does this work? Okay, wonderful. So my name's Jonah. I'm a computer science student here at North.
My name's Abdullah. I'm also a computer science at North.
I'm Jared. I am also a computer science major at North.
And we want to introduce to you our website, Bubble Data, which is a solution that allows educational institutions to make informed decisions about their budgets in order to maximize student success. And hopefully, we're all in the school here. That should be very important to you, right? If we have a way for these institutions to allocate their budget in such a way that they're putting the funds towards resources that help students as much as possible, we all benefit. So let's take a look. So the problem that we were trying to solve, as mentioned, is creating a way for educational institutions to analyze their students' data and to easily have a way to figure out where their funding should go and what factors are most involved in either increasing or decreasing student success.
All right. Yeah. So the main design of our project was based around bubble graphs. We felt that bubble charts, right? Fortunately, we don't have a graphic, but you'll be able to see it at the end when we give you the website. We have a little demo. All right, so we felt we chose bubble charts, right, because we felt that they give a really good overview of like a lot of different variables and how they could possibly affect a given outcome, right? And we really focused on grades, so we wanted to figure out what variables of a student's identity are going to affect the overall grades of the school, right? And yeah, so and I'm gonna jump down to the bottom slide, or not slide, bottom point.
Let's do it.
Oh,
bottom slide. Bottom point. Okay.
Yeah, about optimization, right? So we want to minimize the kind of whole point of our project is to help policymakers or officials, school officials, to make the right decision to minimize costs. Obviously, the school doesn't want to spend as much money as possible. They want to spend as little money as possible to have the greatest student outcomes, right? And then another core part of our project was simplicity. We want this to be very simple, and we want it to be shareable. So yeah, we have this share feature where you can send data to your colleagues. Yeah, so future plans for our project. We want to add some accessibility options. So with the color, the bubble charts, there's some colors on there, and we felt that you know, if say if you're colorblind, the colors might look similar. So we want to add some accessibility options to I don't know, contrast and make the data easier to read for everyone. As well, we want to add some non-numeric values. Right now, it's mostly focused on stuff like age as variables and like household income and that sort of numeric value. So we're looking to add support for non-numeric values. As well, if you want to help at all, it's open source, and we'll give you the link to the GitHub repository at the end. So yeah.
Okay. So the application works by allowing users to upload their own data sets to it. So one of the main things we wanted to do here was to make it completely data set agnostic, which means that whatever your school is, however you choose to collect data, it will work with the application as long as you configure it. And this means that it's usable for as wide of a population as possible, which is one of the main things we wanted to do here. So what the application will do is once you upload your data set, it will go over it and it will let you configure it so that you can specify what variables in your data set you want to analyze, which ones are the ones that you're trying to increase. So in this case, we were choosing grades as the one to increase, and we were looking at the data set and choosing other factors as the ones that might go into grades. And once that's done, once everything's all configured, it will look over the data set and it will use a multivariate linear regression in order to figure out which factors are the most correlated to student success. And it will present it to you, and we'll see that in a moment, in a very nice format that makes it very clear what factors are the most important and which ones either increase or decrease success. We also added a mode where you can specify variables that you can control. So for example, you might be able to control how much study time students have. You could maybe put programs forward in order to encourage students to study more. Now, what it's able to do is it's able to look at the variables that you have the ability to control, and it's going to look at how much it might cost you to do that. Now remember, schools have limited budgets, right? All of them do, no matter what school it is. So it's critical that the budget is used as effectively as possible, which is why we added this option. So it will look at the data, and it will be able to analyze it and give you an overview of the different sources that would be the most effective to put your money towards. And it'll give a percentage breakdown of different variables that you might be able to increase in order to optimize and maximize student performance.
So something when we were just building the site was we had to decide our back end and engineering. So we decided to use Next.js as it is a widely known and industry standard full stack framework, React framework, and we used D3 to help compute our data visualization. So D3 is the backend library. It is also pretty much industry standard nowadays. So if anyone would like to go into it, it's very platform agnostic. And we are using Material UI, which is developed by Google for our UI, and MLJS for our linear regression. So other key things of note, our demo data is from Portugal. The app, as we've stated before, is not limited to the data set. And bubble data can help inform officials because this app wasn't designed for, let's say, all of us, but more so for people who are in positions to make decisions. So this, whilst it's not, we might not see this application ourselves, it would be very useful for the officials.
And one thing on that front that we noted is that the people who might be analyzing and collecting these data, they're not always the same people who are the ones making these decisions. So we decided to add a very easy, there's a share button on here that makes it very easy. Once somebody inputs all their data and configures the application, they can share it, and it creates a nice dashboard that can be sent as a link to anybody, maybe the higher up that's responsible for managing the funds.
And to add on top of that, the analysis is private. It is all handled on the client. So there is no data being sent to the server, which means there is zero chance of being compromised. As long as the backend is not compromised, there's no such thing as a data leak because there is no data to leak. So long as the code isn't compromised, it's very secure, and the only data is in the URL you share. So the thing you might worry about is this URL you share. There is no backend that will be of concern that could be hacked.
So I want to, we have a video here, but first, why don't we pull up this QR code, and you can all pull this out. Now, we're going to watch the video after so you all know what to do, and you can sort of follow along. Let's move out of the way, make sure everyone can grab this. If you're on a laptop, I also have a link that you can go to. I'll switch that in a moment once I see some of the phones start going down. Got a few more people. Let's see. And if the QR code isn't working, you can use the link as well. So let me go over to that. It is, it's this one. It's this middle one right here. You see where it says websites? Now there's also this other detail. So if you want, you can check out the full source code for it here. I'm going to go back to here once we do the video, and you can view the example data set that we've been using. Now remember, you can choose your own data set and put it in. It'll work perfectly fine the same way. So let me give people just a quick moment. And let's check this video out.
So we've already set up the configuration, but if you'll notice, this is the graph that is generated. So red is negative, blue is positive, and the size of the circle affects how much is important. And that is the analysis from the variables we can control. When we have our about page, and we can go back to the columns. And it's a very simplistic UI, as you guys noticed. But to configure it, if you notice, you can just specify the variable type over here. So right here, this is a normal variable. So it is normalized and considered pretty much as any other variable. For, that's on view, but you can also specify controlled. So in the analysis site page, you'll see this will show up in the analysis of how much this affects it and how we can optimize it. And there's, of course, we have two more options, which is being the output, so the grade in this situation, and finally, is it numeric? So we haven't completely implemented that.
Yeah, so numeric variable. So one of the issues is that these data sets, they can do two things. So they can either have, like let's say, what's an example? Do they have a job? It'll say yes or no, which is not a number. And it can also be something like, what type of job do they have? Is it in the service industry? Is it in, are they selling goods, right? So we do have a way to handle those pieces of data. And you can see, maybe if we go back a little bit, but on the display page, you were able to see that, yes, there we go. So here's an example. So this is, we have a few here. So we have information such as the school, such as the sex, such as the address. These are non-numeric. Now we'll handle this, but maybe the display doesn't have, there's still improvements for us to make in the display of it. Now internally, it is able to handle them perfectly fine. Now the last variable type there is ignored, because obviously maybe there might be some information that just doesn't make sense to analyze. But you still might want to just have it be a little bit easier on you and upload it there without having to do a little bit of extra processing. We added that so that it deals with it for you automatically. And if any of you all have pulled it up, what you'll notice is that all of the variables are ignored by default, so it's not going to do anything. You're going to have to configure it, and what you'll do is you'll set some of the variables to normal. In fact, most of the variables should be set to normal, and all the way at the bottom, this is how this data set is laid out. There's 3 columns. There's G1, G2, and G3. You'll want to set those to outputs. And you can also rename them so that they show up differently in the display. Here, they're in the format specified by the data set, so it's all lowercase, but you can modify the names so it shows up a little bit nicer in your display if you want to make it pretty for your boss.
I also did want to point out that this is a truncated value of the coefficient. So if you'd like to see the fuller version of the coefficient, you can just hover over it if you're on desktop. So we did optimize this page for desktop experiences, considering this is mostly going to be used as a work tool, not a on-the-fly by students. But we did acknowledge the necessity for mobile in this day and age. So whilst it is mobile compatible, it has been explicitly designed for the desktop experience.
And if you have pulled it up, there should be 2 buttons. There's a button that you can use to load your own custom data set, but I'm assuming most of you don't have a data set. So we've also added a button to load an example data set, so you can still give it a try. So the bottom button is the one that you want to click. Then in there, you'll be able to configure your columns. Then if you see that sidebar right at the top left, if you click that, you will be able to open up the visualization and the analysis page.
And those are computed on the fly. So once you enter everything, you just click on it, it's right there immediately.
Should we go through the video? All right.
Any questions?
And let's go back here.
Okay, so let's say the administration gets their hands on this. What are the specific actions that they can take using this software?
So let's go back here. Oops, well, it disappeared.
Well, first of all, this tool is very efficient at calculating correlation. So if this school were to... Correlation of what? Correlation between any 2 variables. So it doesn't need to be grade. It could be absences. Like, how do we minimize absences? How do we maximize student participation? We've designed it to be agnostic to what data we want to find correlation for. So if we implement it here, we would be able to find correlation. This is different from causation. So if you see, the grades is affected a lot by failures. Well, yeah, but is failures the cause of your being a low grade? Maybe not. Maybe there's something else. That's just a correlation. So this gives you correlations, not causations, to be very clear.
Okay, yeah, that's a sufficient answer. And now just kind of thinking this as an idea for what you guys have, maybe you could add some sort of alert system that say, hey, or make it more clear what the correlations are, because I guess someone who didn't work on it, that wasn't clear, but you answered the question, so no fault on you, but maybe like moving forward, if you want to keep working on this, maybe make it clear in the UI what is correlated, and yeah.
So I noticed you specifically called out linear regressions for your statistical method. Is that the only kind of statistical method you're using to produce these graphs, or?
Yes, that's the one that we're using here. So we were fairly pressed for time, and we also are not the most knowledgeable in statistics. So we were hoping to use like a polynomial regression. We were not able, so we're using, let's see, we have an acknowledgement page, or the stack page back there. Let's get to it. So we are using this library, MLJS, is handling the linear regressions for us. I think in the future we would want to expand it to something that's more powerful. However, a lot of these factors likely are going to have linear or close to linear correlation. Like, for example, your study time, if you study more, your grade probably goes up at a linear rate.
And I do want to specify that it is super easy to switch out the algorithm used on the back end. We have designed it, because we are working on a team, we decided we are going to work as a team. So we just make interfaces between each other. So the viewer, the display component, is separate from the regression component. So that is very interoperable, and you can hot swap whichever. If you implement two algorithms, you can actually pretty much hot swap them on the fly. And that, thanks to the modern web, that is very easy.
All right, sounds good. Thank you.
Hey, I wanted to ask, because you said that you can import your own data set. Is that data only in the form of like one row to one column, or could it handle, for example, multiple worksheets or a column that has multiple pieces of data in a single column, like separated?
Yeah, so for this one, it's just going to be able to handle data that's set out where you have multiple columns, each are specifying a different data point. In this case, so the data set that we were given had multiple output columns. The way that we implemented this was we take the average of all the output columns that are specified. So it can do that, but really what it's more oriented towards is single columns with a single piece of data. Now it can handle those types of columns where you have, for example, a job type. And it can maybe say that different job types are more correlated or less correlated towards having a better grade. And that maybe adds the potential for handling more complicated situations. But for this one, yeah, it's just going to be one piece of data per column.
And I did want to specify that we did have a system in place where on hover, you would be able to view a graph of what the predicted coefficient is. And whilst because we were pressed for time, we weren't able to implement it, but it was in the design docs to eventually add, if you're like X, like it's an enum type more, you will be able to view a sort of a histogram of how each one affects.
All right, thank you.
Hello? Okay, yeah, that was great. Next team up, Mango Tart. Ready to go? You guys got this.
Where's the other mic?
Hello? Hi everyone, my name is Do. You can call me Troy. I'm a student, senior student studying AD programs at North Seattle College. And before we get started, I want to ask one of you, how do you find these events? How do you find Impactathon?
It's fun.
But how do you know? How do you get notified about this event?
Somebody told me about it.
Right. So you got invited, referral. You get referred. Is there any other ways that you get to know about this event? Flyers. So flyers, you have to be physically in school to get to know about this event. Nowadays, community engagements, to get to know about these events, you have to have access to certain things to see the events occurring, like schools, emails, Slacks, or flyers. So you need an access to be able to introduce to the events. That is the limitation of the community engagements, because you need to have access to certain things to be able to get the door to attend to community events. So I am speaking as a student. This is my last quarter at North, and after this, I'm currently looking for jobs and opportunities. And finding events is one of the crucial things to do, so I can build connections, meet new people, because they are an opportunity that can help me better my future in tech, and also can help me land a job or an internships. So community engagement is like a door for everyone's personal growth or career growth. So since this is a limitation for event access, in the past day we came up with the social platform named Core. Basically, this social platform is a event hosting and management for community activity. I'll hand this part for Amna. She will get into the events, the social platforms.
The aim of our platform is to get high school students engaged with the community and enhance their experience in finding relevant events that are happening in their communities. So CORE is a social media platform for hosting and organizing in-person and virtual activities for schools. It makes it easy for students to find events that are happening in their community that's relevant to their interests. So one way it does that is similar to many other apps. It gathers information from the user. So when you log in and you create an account, it'll ask you, what are your interests? Like, do you like math? Do you like computer science, chemistry, biology, all that stuff? And based off of that is what your feed will look like. And then it also provides feedback. So it has a feedback feature. So when students go to events, they can rate how that event was for future students to see do I want to go to this event? Should I be going to a different one? And also you can provide feedback on the features of the app itself. So things that you might not like or things that you can improve about the app. And then there's also access for parents. So parents can also access the app and help volunteer, because many events require volunteers, so parents can see events that are happening in the school in that area and choose to sign up to volunteer.
And one of the features we wanted is to incorporate AI use.
and it's to help with the technical difficulties that users have when they're accessing the site, wherever it's like through mobile or on the website. And we want to also use like the student data set from the school, and it's to help generate the events and community for the student users, depending on the interest tags that they put in their profiles. And also it reduces the burdens of the students to search for events, because we wanted to make it easier for them to access, and they don't have to think about it too much. And they can also, if they have the time, they can also search for it. And it's, and we also made a reward system, and so you can get points for the participation, and there's many like tiers that you can get rewards to choose from, and they're like student discounts, souvenirs, gift cards, and also you can get rewards for referring other students. And we wanted to do this because it increases the engagement from the high school students to the communities, and also to be able to meet new people and build connections. And because of the positive outcomes, students are more likely to engage in those activities and attend events.
And our goal is to deliver a user-friendly application and focusing on user-centered design. Our applications will be multiple platform, meaning that user can access the application on any device such as iPhone, Android phone, or computer. With mobile devices, we can develop a mobile app. And on the mobile device, so far we came up with 3 options for event design. First of all, it's going to be sliding events horizontally, or either slide events vertically, or just simply tap left or right of the phone screen to browse the volunteer opportunities. With the web applications version, we will develop a web app with cross-platform, meaning it will be supported by any web browser such as Firefox, Google Chrome, or Safari. The application including a search bar. Can we go next slide? So if you can see on the top, we have search bar that allows user to look up any opportunities quickly and easily by providing specific input. Our team has recently explored the possibilities of using AI technology to assist user. We have decided to add a virtual assistant in form of a chat bot that can answer basic questions based on the information available in our database. For example, a user can ask using the chat bot by questions, where's the location of the event, and the chatbot will respond with the detail of that event information. Moreover, we plan to incorporate AI to provide like suggestions or recommendations for suitable opportunities based on the user profile. And
so that is what we came up in the past day. With this social platform, we believe we can bring humans' connections together in the simplest way and the easiest way they can, even from small scales such as nonprofit organization to larger scales, aiming for high school students and college. But in the future, it can be accessible for any social events out there. And yeah, if you have any questions, I'll be here.
Questions?
So you put on a lot of demonstration about the design and the potential goals of the application. Does this exist yet? Do you have a working demo, a mock-up, anything?
No, we haven't created the app. This is just the idea that we all gathered.
Okay.
But in the future, we may make it happen.
Sure.
So in terms of like making the app, like what languages were you thinking about doing, and also like did you guys like make mock-ups of the interface or anything like that, or?
I can answer this question. On the Android applications, we can use like Kotlin Jetpack Compose, or on the Apple version, we can use React Native or Swift. On the web applications, we can use like MERN-Stack to develop the web applications.
Did you do any drawings of what you were thinking you might like, how you might organize it or whatever? Or?
No, we haven't created the final form of the app structure, the user interface. But yeah, what we have is the basic designs of the design of reels or swiping or casserole user interface. But yeah, but because our goal is to make the app simple by using one of the latest trends in social media like TikTok or Meetup.com or Instagram, where the user will just consume information easily and fast. That's our goal.
Thank you.
Any other questions?
Thank you for listening. All right. Thank you so much, guys, for listening to these presentations. We're going to go ahead and give the judges time to go upstairs. They're going to start deliberating. Feel free to grab some food and talk with each other, network with each other, all of that. But the judges are now going to go start deliberation and figure out, who they think deserves which prizes. There will be prizes, I promise.
Prizes. Waste day basically because Congress sends it. Okay.